Hello, let's do the New York Times Medium Sudoku for May 8th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. So let's go over some terminology first. This is a cell. There are 81 of them in the grid. A row of 9 cells is called a row, and this is a column of 9 cells, so row and column. And then this is a box. Now the boxes are only the bold outlined ones. So there are 9 boxes in the grid as well. These are all boxes. All right, in addition to that, so Sudoku rules, first of all, tell us that in every row, every column, and every box, we are placing the digits 1 to 9 exactly once each. So they appear exactly once, not 0 times, not more than 1 time. So they can't repeat. And every cell will then, of course, end up having a digit in it. Now we're also going to be calling a row of 3 boxes a band and a column of 3 boxes a stack, just convenient terminology there. If I ever use the word house, house is a generic word for any row, column, or box. So just anything where you're placing the digits 1 to 9 once each, that can be called a house generically. Okay, now that terminology is out of the way, we're going to take a systematic approach to this solve. This is for useful as a teaching tool and a learning tool, so that you can see the important things to look for first. You don't have to take this strict systematic approach, but I do recommend trying it out so that you can get a feel for what sorts of things you want to look for in your solves. Okay, so the first thing we're going to do in our systematic approach is we're going to go through each of the bands. So we're going to do each band one at a time, and we're mostly looking for things that are visible within just the band. We are going to be peeking out a little bit, and I'll explain why when we get there. But mostly we're focused on just the band that we're looking at. So first thing we're going to do is we're going to look for digits that appear exactly twice in the band. Now, you can probably figure out, because the band is made of 3 rows and it's also made of 3 boxes, each digit will appear exactly 3 times in each band. For a total, since there's 3 bands, that's a total of 9 instances of each digit. Right. So when there's 2 already appearing in the band, the third one is quite limited where it can go because it's not going to be in the same row and it's not going to be in the same box as the 2 digits that already appear. So it'll be down to 3 cells. So let's go over that. So the first thing I'm going to do is I'm going to compare each box against each other, and I'm going to look for repeated digits. Now, we only need 3 comparisons because there's 3 boxes. We need to compare box 1 against box 2, box 1 against box 3, and box 2 against box 3. Now I'm going to be a little bit efficient here, and I'm going to look for the box with the fewest givens in it, and I'm going to focus on that. So that's this box here. It has only 2 givens in it. And I'm going to just look for those digits in these 2 boxes kind of simultaneously, so the 1 and the 5. Because I picked the box with the fewest digits, I have the fewest numbers to think about. So 1 and 5, I don't see any 1s anywhere, but I do see a 5 here, and I don't see a 5 here. So we end up with 2 5s in the band. So we have found what we're looking for. So this 5 is in this row, and this 5 is in this row, and also this box and this box have the 5 as well. And so these are the 3 cells that we've reduced 5 to. Another way to think about that is this box still needs a 5. These 2 had one, this one doesn't. This 5 says not in these 3 cells, and this 5 says not in these 3 cells. And so we get the same result, that 5 needs to go in one of these 3 cells. Now, of course, you've probably noticed by now that these 2 cells cannot be 5 because they are a 2 and a 7. So you can't put more than 1 digit in a cell. So there is actually only 1 cell in this box that can be 5. And in fact, in this entire band, we need a third 5, and there's only 1 cell that can be that 5, right? So that is called a hidden single. And so whenever we've reduced a house to having only 1 cell that can have a digit, that house must have that digit, right? So we need a 5 in this box. There's only 1 cell that can have a 5, so that cell must have a 5. We can place the 5. Hopefully that's clear. All right, and so now that we've done that, we are going to continue, and we've finished comparing this box against these 2. So now we just have to compare these 2 boxes against each other. And I'm going to pick, again, the box with the fewest givens when possible. I'm going to look for a 4, 5, and 9. Now, 5 we already took care of. It's good to remember that we already took care of the 5, but we can also see that it's taken care of. So the 4, there is no 4 in this box, but there is a 9. So we have these 2 9s. They look into this box. And here's where we're going to look down and see if we have any 9s helping out down here. That's the only time we kind of dip down out of the band. We do see this 9 here. So that 9 helps by taking 9 out of that cell. So there's actually 2 cells in this box that can be 9. So that's something that we want to remember, but we can't just place the 9 because we don't know which cell it goes in, and we're not out here guessing. If you start guessing, you're going to guess wrong, and then you're going to break the puzzle, and then you're going to have no fun trying to backtrack figuring out which guess was wrong. You don't want to do that. So instead, we're going to use notation. And we're going to use corner marks here. I'm going to go into corner mark mode here. And I'm going to corner mark 9s into the 2 cells that 9 can be in this box. And corner marks will always mean, when we use corner marks, it will always mean that within this box, the corner mark cells are the only cells that can have that digit. So it's an exhaustive list of cells. So in this case, 9 is in one of these 2 cells, and we corner mark that. All right, and that's how we're going to remember it. Now that is all the repeated digits. Before we move on to the next band, there are 2 more things I want you to look for. You sometimes find them, sometimes don't. First thing I want you to look for is a filled box row. So if a box has a row that's completely filled, like here, we don't care about the whole row, right? Just within this box, all 3 of them, we basically know what 3 digits go in these 3 cells. When we have that, we want to look at the 2 rows that aren't that row in the 2 boxes that aren't that box. And what we're going to do is we're going to ignore any cells that don't have digits in them. And we're going to ignore any cells that have digits that are already placed in the box. So this 5 and the 5s, basically. Now we're down to this 1 and this 4. We're going to take them one at a time. If you get a little bit more advanced, you can take them both at a time and notice something here. But we're not going to worry about that right now. So we're going to take this 1. And one way I like to think about this is this 1, none of these cells are 1, right? They're 2, 5, and 7. So where would the 1 be to buddy up with this 1 in order to take 1 out of these 3? And the answer is it would be over here somewhere. So if we had a 1 over here, like let me just place one real quick. If we had a 1 here, these 2 1s would look into here, and we'd have the same result as this getting filled with non-1s. And so we'd have that buddy there, and then the final 1 would actually end up here somewhere, and actually would be exactly here because this one looks up. So I think it's pretty easy to see logically that the 1 in this box can only be here because this one says not these cells, and this one says not these cells, and these are filled with non-1s. So we actually have a hidden single 1 in this box, which is right here. And then now these actually are buddies. They look in and look, the buddy 1 that I said would be here is actually over here. We don't know which cell it's in, but we can corner mark that. And that's always going to happen because this row is going to need a 1, and this one says it's not here, right? So it's going to end up over here. So there's a lot of ways to see that. We'll go over a few different ways. Once we get to pointing, once we get at something pointing, I'll explain that as well. Now this 4 also, let's do this little exercise again. Where would the buddy 4 be? Well, it would be a 4 that takes it out of these 3 cells that's not in this box. It would have to be in this box. So it would be in one of these 3, but these 2 4s that we look down, it says not here. So it'd have to be a buddy 4 here for this 4, and that would place a 4 here. And those are actually true. We can work through this backwards. This 4 looks in here. None of these are 4. So we place a hidden single 4 in this box. That 4 looks in this box. This 4 looks in this box. We have these 2 4s looking up. That places the 4 here. Perfect. Okay. So that's what we did with this filled box row. There are no other, there is this filled box row now. So we could look at these cells, but we're not going to find anything new. The 1, 5, 4, and 9 are already taken care of. So we're done with filled box rows. You can see how that was very nice to find, very nice to utilize. And so the last thing we want to look for before we move on to the next band, and it's nice that this top band has actually demonstrated everything. It doesn't always. Is that we want to look for rows or boxes that we want to look for rows or boxes that have been reduced to 4 or I can't talk right now. I don't know why. I'm going to do this one more time. We're looking for rows or boxes that have been reduced to 4 or fewer open cells. The fewer, the better. So I'm going to start with the fewest. This box has been reduced to 2 open cells. So if you think about it, that means there's only 2 digits that are missing from this box that need to be placed, and they're going to go in these 2 cells. So let's think about what those 2 digits are. Well, we have the 1, 2, 3, 4, 5, and 7 and 9. So the 2 digits I didn't list are 6 and 8. So we know that the 6 and the 8 are going to go in these 2 cells somewhere. It's either going to be 6 here with 8 here, or 8 here with 6 here. We don't know which order it goes in, but we'd like to remember that. Now we could use corner marks for that. We could put 6, 8 here. That would be perfectly fine. But actually, we're going to use center marks for that. And what center marks mean is they are a cell centric, right? The quarter marks were centric to the box. They were telling us where that digit goes in the box. The center marks are just saying this is the comprehensive list of digits that could end up in this cell according to our current state of the board. So this cell is going to be a 6 or an 8, and this cell is going to be a 6 or an 8. And because these two match and they share a row, and they also share a box, but we'll pick one. They share a row, which means that they can't be the same digit as each other. They cannot both be 6 and they cannot both be 8, right? So one of them will end up 6 and one of them will end up 8 because there's only they can only be 6s and 8s. So if one is 6 and one is 8, that means the rest of this row can't be 6 or 8 because the 6 and 8's over here. So the row doesn't care how it resolves. If this is 6, 8, or if this is 8, 6, this row still sees an 8 and a 6. So the result is that these three cells are going to be the three digits that aren't accounted for yet in this row. 6 and 8 are accounted for. So we need the 2, 3, and 7. And so I'm seeing here, this cell, I'm peeking down, I'm seeing it sees a 2 and a 3. So if the only digits left for this row are 2, 3, and 7, and this cell can't be a 2 or a 3, then it must be a 7. That's called a naked single. Because if we were to list all the candidates this can be, it can only be 7, and therefore it must be 7. It's not about where 7 goes in the box. It's not about where 7 goes in the row, right? 7 seems like it could go anywhere here. It could go anywhere up here. But this cell needs a value, and it cannot be 1. It cannot be 2, 3. Cannot be 4, 5. It can't be 6 or 8 because of the 6-8 pair, and it can't be 9. So the only digit I didn't list is 7, so that is the digit it is. It's a 7. Now that leaves a pair over here behind, the 2 and the 3. We don't know which order they go in, but we can center mark the 2, 3 there, and that is a 2, 3 pair there. Now, because we know the 3 is in one of these two, we actually have a buddy for this 3 now. We don't know which one it ends up in, but the buddy acts in the same way, and that is going to put, and this 3 also looks in, that's going to make a hidden single 3 in this box. We didn't actually need this because this was filled. We filled this with the 7. So, but it's the same result. The 3 ends up here. Okay, so we're doing really well here. This 7 also, let's follow up on that. We have these two 7s looking in, so that is going to corner mark 7s up here. 7's in one of these two cells. This is also filled, so we want to look to see if we missed anything here. The 5 is accounted for. 9 we already have corner marked. 7, 1, 3, 5, 4, but we didn't account for the 2. So we know the 2's buddy is down here, and then this 2 looks up, so 2 ends up in one of these two cells. Okay, so we followed up on these placed digits. We made sure we found their buddies. But we still have some rows that are down to 4 or fewer and boxes. So we're going to take the one that's the least remaining, which is this row. What do we need? We need the 1, 6, and 8. So I'm seeing that this cell can't be 1, so it's down to 6, 8. And this cell can't be 8, so it's down to 1, 6. And this one's down to 1, 6, 8. Now, I'm always willing to center mark a cell if it's down to 3 or fewer candidates. I'm very, very unwilling to mark it if it's 4 or more, unless I'm desperate. And usually in these puzzles, I'm not going to get to that point. So generally 3 or fewer, good to mark. 4 or more, you're just cluttering the grid. You're not going to actually find use out of it very easily. And so really you're just adding things to look at that you don't need. Okay, so the other thing that I noticed is that this box is down to 4 open cells. And actually we can reference our corner marks and center marks. We can see it's 2, 6, 8, 9. Now these can't be 2, so this is down to 6, 8, 9. This can't be a 9, so this is down, and it can't be a 6. It can't be 6 or a 9, so it's down to 2, 8 only. And this one can't be 6, so it's down to 2, 8, 9. Okay. And now actually this box here is also down to 4 because according to the box, it doesn't care which one ends up 2 and 3. This 2, 3 pair we can consider resolved from the perspective of the box and from the perspective of the row. The columns do care. They are not resolved by the columns because they don't share a column. But because they share the box, there's only 4 digits left for this box, the 1, 6, 7, and 8. We know this can't be 6, so this is 1. Sorry, it can't be 1. Sorry, not 1. Oh yeah, we do need a 1, but neither of these can be 1. So this can't be 1 or 6, so this is 7, 8 only. This can't be 1, so this is 6, 7, 8. And it's not an 8 either, because the 8 in the column. So something I'm noticing is that in this box, because of this 8, in this box, the 8 is actually in one of these 2 cells. So we can corner mark that as well. Might as well. Okay, so now we've thoroughly investigated this band. This is all we're going to get out of it on its own. We're going to need the bands below it to help it out, to sort of poke in. So we're going to move on to the next band now. I'm starting with this 7. We see no 7s. So now I just look at the 2 and the 6. We do have this duplicated 6. We're looking for a 6 up here. Unfortunately, we did not place the 6 in this box. So 6 is still in one of these 2 cells. That's the only repeat. Do we have a filled box row? We do not. Do we have a row or a box down to 4 or fewer? We do not. So we move on to the next band. I'm going to start with this 3, 8 here. We do have a 3 here. So these 3s look in. We have this 3 up here looking down. So 3's in one of these 2. The 8 does not have a buddy. Now, something you may notice at this point, just because you're looking at the 8, you may notice this 8 looks in here, and these are all not 8. And that does put an 8 in one of these 2 cells. So let's actually notice that, and let's use that. It's not one of the things we're specifically looking for, but if you do notice anything incidental like that, feel free to use it, even if we're trying to be systematic here. There's no reason to ignore logic that we found. So what does this mean, right? With this 8 looked in here. These aren't 8. 8's going to end up in one of these 2 cells in the box. Well, according to the column, it does not care which one of these ends up 8. We know one of these will be 8, and the rest of the column doesn't care. It means that it can't be 8. Because if the 8 ends up here, notice this cell can't be 8. Otherwise, the 8 will end up here. This cell still can't be 8. So these both agree that the rest of the column can't be 8. It's called pointing. Whenever you restrict a digit in a box to a single row or column, that will restrict it out of the rest of that row or column, in this case, the column. So we restricted the 8 to just a single column in the box. That's going to point and restrict that digit out of the rest of the column. So this cannot be an 8 because otherwise there would not be a place to put 8 in this box. That's another way to think about that. So none of these cells are 8, right? We're just going to have to try to remember that these aren't 8 because we don't have a good way to mark that right now. And I'm not really going to center mark those at this point, but that is helpful. It means this cell's not 8. Okay. So we noticed that. That was nice. But that was the 3 and the 8. Now I'm going to look at the 1, 2, and 9, comparing against here. We don't have a 1 or a 9, but we do have a 2. So these 2s look in. This 2 looks down. We have a hidden single 2 in this box. That 2 now resolves this 2, 3 that we had here, because this can't be 2 anymore. Well, if it can't be 2, then the only digit left that it can be is 3. That's a naked single. That means we're down to just the 3, and then that's a 2. By the way, hidden refers to house-based logic, like we're looking for digits within an entire house. Naked means we're looking at cell-based logic. That cell has been reduced to those digits. That's naked. Okay, so basically, hidden's going to use our corner marks. Naked's going to use our center marks. Is a nice way to think about that. Okay, so we placed that 2. That gave us this 3 and this 2. Now, we always want to think about whether we can follow up on that 2 and 3, but we really can't. I already knew we couldn't. Because the row doesn't care how it resolved, the box doesn't care how it resolved, and we haven't scanned the columns yet. So we're not worried about that. Okay, so that was the 2. The 1 and the 9 don't do anything at the moment. Do we have any filled box rows? We do not. Do we have any rows or boxes down to 4 or fewer? This box is actually down to 4 or fewer. This is where we would have noticed the 8s had we not already. But what are the digits remaining in this box? Well, we need the 1, 5, 8, and 9. So we're scanning all around for 1s, 5s, 8s, and 9s. I'm seeing quite a lot. First thing I'm noticing is this 1 isn't here. So it actually puts the 1 in one of these 2 cells. Let's follow up on that immediately, because this is pointing again. This is pointing and saying the rest of the row is not 1. So basically, this 1 has a buddy. It's in one of these 2, right? And so the final 1 ends up here. So one of these is a 1. Handy how that works out. What else did we need in here? We needed a 5. We know this cell can't be 5. It's not 5 and it's not 8, right? Because the 8 is here. This 8 says not 8. So the digits remaining are 1 and 9. No, it's not 9 either. Right, so this box needs 1, 5, 8, 9, and this cell is not 5, 8, or 9. So this cell is only 1. So we actually get a naked single 1 there. Even better than the ones we marked. Now we're down to 5, 8, 9. And this cannot be 8. So this is down to 5, 9. And these are down to 5, 8, 9. I'm just going to mark those because that is 3 digits. And we see this 9 also helps us out. So 9 ends up in one of these two. We can corner mark that if we want. Okay, so that was that box. Remember that we looked at it because we were down to 4 or fewer, and that was quite handy. Now here's something that you probably will notice, and let's just do this now, is we filled this 1 here, and this column is almost done, right? There's only 2 open cells in it. The 2 and the 8 are the final 2 digits we need in this column, and this cell can't be 2. So let's fill this 8, right? This is a naked single 8, and then that makes this a 2. So we finished the whole column. The 2 actually gives us this 9, and that leaves a 6, 8 pair here, which is quite handy. The 9 also looks down, placing this 9, leaving a 5, 8 pair here. So I'm actually going to focus on this stack now because it's almost done, right? We can think about these cells here. There's only 2 cells left for this column according to the column, so it doesn't care how the 6, 8 resolves. We need a 1 and a 5, so that goes here. And here this triple is 2, 3, and 7. We can see that this top cell can't be 2 or 7, so it's down to just 3. So we can place the 3. All right, you can see why I focused on this stack just for a second, a little bit early, just because it's so full. Now we did place the 9 and the 1. We need to make sure we follow up. We did follow up on this 1 already, but the 9 looks into here. This 9 looks down, so we need to corner mark the 9s here. This is also filled, but you don't need to worry about filled box rows or box columns when the box is already completely known. We know this is a 5, 8 pair. That's all we're going to learn, because what we learn about it is internal to the box. Let's just make sure we didn't miss anything else in terms of buddies. There are no other filled box rows. Any rows or boxes down to 4 or fewer. This is 5 cells. This is 5 cells. This is 4 cells. Okay, so this row, what do we need? We need a 3, 4, 5, and 7. Now I'm noticing this can't be 3, 4, or 5, so this is a naked 7. And now we're down to a 3, 4, 5 here. Notice this can't be 3 or 5, so this is a 4. This can't, sorry, well, and this is down to a 3, 5 pair. Whoa, my throat is not happy right now, sorry. Just need water. All right, now that this is a 3, 5 pair, notice how the box doesn't care how the 3, 5 resolves. They're going to end up here. So these 3 cells are a triple that remains. The remaining 3 digits we don't know about yet. So those are going to be the 6, 7, and 8. I'm just going to fill that out, but actually this 7 tells us it's not here. So we can actually just place the 7. And then now we're down to 6, 8 here. We can fill that pair. Now, does the row care how this 6, 8 resolves? It does not. All it cares is that this 6, 8 ends up over here. So this cell is not going to be an 8. The 6, 8 pair removes 6 and 8 from the rest of the row. So this can't be an 8, meaning it must be a 5, and that makes this an 8. That leaves a pair behind for the rest of the row. It's going to be a 1 and a 4, it looks like. That leaves a triple, either for the box or the column. It's going to be the same triple. They're going to agree. It's going to be the 5, 6, and 9. This cell can't be 6 or 9, so it's a 5. And that leaves a 6, 9 pair here. Oops, 6, 9 pair. Very nice. Okay. So that finishes that band for sure, right? We know a lot about that. Next thing we're going to do, now that we're done with the bands, is we're going to do the same thing with the stacks. So just basically think about rotating the puzzle 90 degrees and doing the bands again, but we don't need to rotate it, right? We can just look at the stacks, and every time I said row, just use column instead. So we're going to start in this box with the 2, 6. The 2s are done already. We have all 3 2s. The 6 actually does not have a known buddy, so we can't do anything with that. Now I'm going to look at 2, 3, 5, 7, 8. So the 2s are done. The 3 does have a buddy in here. This 3 looks in as well. 3's in one of these 2. The 5 has a buddy as well. 5 ends up somewhere up here in one of these 3. Then 7 and 8 We don't know much about 7 and 8. I am seeing we have this 7, 8 here, but that's not really super helpful. Okay, so that's the repeats for this stack. Do we have any filled box columns? We do not. Do we have any columns or boxes down to 4 or fewer? Yeah, we do. So let's start with this column. This column's down to 4. It is the 1, 6, 8, 9. We know neither of these are 6, and this one's not 9. So let's fill this out. It's 1, none of them are 6, and then 8, 9, and this one's not 9. And every time I place these, by the way, we are on the lookout to see if we had any pairs or triples that got formed. Like I'm looking over here, I'm looking up here, and I'm also looking to see if that caused if there's any hidden singles in the column. If there are any, I will point them out. All right, these two cells are down to 1, 4, 7, 8 for the column. This cell can't be 7 or 8, so this is down to 1, 4. And this is exactly what I just talked about, which is we want to be on the lookout for pairs. As soon as I place this 1, 4, I'm looking at the row for 1, 4s, I'm looking at the box for 1, 4s, I'm looking at the column for 1, 4s, and we find one. Usually you don't, but when you do, it's very handy. So this is a naked 1, 4 pair in the column. Because these two share a column, they cannot be the same digit as each other. And the only digits available to them are 1 and 4. So they will be a 1 and a 4. The column does not care how those resolve. It doesn't care whether this is 1 or 4. It doesn't care whether this is 1 or 4. They're going to be different, so this is not going to be 1 or 4. This is down to just the 7, 8 that's remaining for the column. So we end up with a 7, 8 pair and a 1, 4 pair. Very handy. Okay, and as soon as I place the 7, 8, of course, I am scanning for a buddy. I found this buddy. That's not helpful, but we don't see anything useful at the moment. So that was this column. Now, hopefully now you're seeing why we focus on the rows, columns, boxes down to 4 or fewer, because we're usually finding stuff that's interesting to do there. I think that's it for that stack. And this stack we already did. So now we're just going to do this final stack over here. Find a buddy for the 7. We have all 3 of them. So I'm just going to focus on these one at a time. The 1s, look in here. Puts a 1 somewhere in here. We have the 2s as well. This 2 also looks in, so 2's in one of these 2. We have the 4. These 4s look in. This 4 looks in. Putting a 4 in one of these 2. And then we have the 7s that are done, and then the 9. The 9s look in here. This 9 looks in. It places this 9. Now that's quite handy because that removes the 9 from this cell here, and from the rest of the row, of course. But importantly, this cell here can't be 9. Now, as soon as I make this a 1, 8, I scan to see if I have other 1, 8s, if you don't already see it next to it. We have created a 1, 8 pair, and this is a 1, 8 pair in both the column and the box. Anywhere that any house that says these two can't repeat benefits from the pair. So first of all, for the column, the rest of the column can't be 1, 8. So if this can't be 1 or 8, the only digit left it can be is a 6. Now, as soon as I place that 6, notice that one of the 1s and one of the 8s that I had corner marked is removed. And so now in this box, there's only one place for 1, and there's only one place for 8, and now there's only one place for 7, and we finish the whole box. That also finishes this 6, 8 pair. Now, this 6 did finish this 9, finishing the 6. This 1 finishes the 4 and the 1. This 8 and also this 1, 8 pair finishes this 4 and 7. We get the 2 and the 7 here. This removes a 2 corner mark. We literally just placed that, but now we can place the 2 in full. This 4 removes this 4 corner mark, which places the 4 in the box. We're getting the cascade at this point. This puzzle is basically done. Look how many digits we have filled. So at this point, it's just about looking at rows, columns, boxes that are down to 4 or fewer, and just focus on the one with the fewest if you can find it. So like this column here is down to 1, 6, 8. I am going to fill that 1, 6, 8. This one can't be 6. This can't be 8. We have a 1, 8 pair here now. Notice as soon as I place the 1, 6 and 1, 8, I scanned to see if we had any buddies, and this 1, 8 has a buddy. So that does give us this 5 and this 1. That removes this as a 5, but there are still 2 places for 5. Be careful about that. This 1 does give us this 6 though, giving us this 8 and this 6, which gives us the 1. This 6 also gives this 8 and 6. All right, this 1 gives the 8 and the 1. Okay, this row is down to only 1 digit. We know it's the 3. It's still corner marked in there. This row is down to 2 digits. Remember, I'm focusing on rows, columns, boxes with the fewest, and this is down to 2. So is this. So we could have picked either one. We have the 1, 2, 3, 4. We need 5 and 9. This 9 tells us the order. This is the 5. This is the 9. That places the 5 here. We get the 3 and the 5 here. We're down to 3 and 8 in here. This is the 3. This is the 8. And we're done. All right, so hopefully that was helpful. I know I'm going over the same things in every medium. The idea is for you to graduate to watching my hards, which I know isn't great for the viewership of these videos, but I feel like just having a consistent output of these is helpful. And also I do sometimes get comments saying, hey, today the medium was harder than the hard. So this is available for you to reference, even though it is maybe going a little slower than you might prefer. I hope this is helpful, trying to reinforce the basics here. A lot of these solved before I even finished getting through all the bands and stacks. Like I almost made it to this last stack. I did a little bit with this last stack and then the puzzle just collapsed on us, right? So yeah, good stuff today. Hope you enjoyed it. If you did, then why not leave a like, subscribe, and a kind comment below.